Lesson 2 in Chapter 7 deals with inverses, inverse functions, inverse relations, inverses. If you want to think of inverses as switching or opposites of each other, that may be helpful. We're going to start with inverse relations. Relations are simply a set of ordered pairs, and we've got a set of 3 ordered pairs here. This is your original one. If we graph this, it's at 2, negative 1, 4, 3, and negative 3, positive 1. That's our initial one. To find your inverse, so simple. All we do is take our x and y values and flip them. So instead of 2, negative 1, we've got negative 1, 2. Instead of 4, 3, we've got 3, 4. And instead of negative 3, positive 1, we've got positive 1, negative 3. Take your x and y's and flip them. Just to show you on the graph, negative 1, positive 2 is here. 3, 4 is here. And 1, negative 3 is here. What you'll notice, and this is true about all inverses, is they're reflected over that main diagonal. It's true with all inverses and functions and relations. They're flipped over that main diagonal, that y equals x line. In your assignment, you'll be asked to find inverse functions as well as those inverse relations. Inverse functions are a little bit trickier, but I've got some steps to follow. The first one is you're going to change the f of x or the g of x. You're just going to write it as y instead. So change it to a y. Y equals 3x plus 7. Your next step, just like on the last page, we switched our x and y's around, so we need to switch x and y in this, our equation as well. So we now have x equals 3y plus 7. After we've switched our x and y, you're going to solve for y. Get y by itself. So we subtract 7 from both sides, divide by 3. Those cancel, so we get y equals x minus 7 all over 3. And our final step is to take y and switch it back to f of x. But because this isn't the original f of x, this is the inverse of it, we make it look like that, f to the negative 1 of x. And you don't say f to the negative 1 of x, you just say the inverse of f of x. The inverse of f of x. That's how you read that, with the little negative 1. So your answer would be the inverse of f of x equals x minus 7 over 3. Simple as that. Let's go through those steps one more time over here with g of x. Step 1, change that to y. So we get y equals 3x squared. Next thing, switch your x and y around. X equals 3y squared. Next step is to solve for y. So we divide both sides by 3. Y squared, to get that by itself, we have to square root both sides. So we get y equaling the square root of x over 3. And our final step is to change that y back to the initial, what we started with. But remember, we have to do that little negative 1 exponent there, just meaning the inverse of g of x is equal to the square root of x over 3. That's our answer. Along with finding inverse relations and the inverse functions, we also need to verify inverses, meaning, hey, how do you check or prove that these two are inverses? And it's not too tough. What you do is you do the composition of functions. F of g of x. So we're going to take g of x, just like we did yesterday, and put it in to the function f. So we get 3 times 1/3 x minus 3 plus 9. You're going to multiply things out. 3 times 1/3 is 1x. 3 times negative 3 is negative 9 plus 9. The negative 9 and the positive 9 are going to cancel each other out. We just have one x, or you could write it as x. That's how you know if it's an inverse. If you plug one function into the other function, and when you simplify you get an x, then they're inverses. If you plug one function into the other, and when you simplify you get just an x, then they're inverses. But because we have to check and make sure they're truly inverses, we have to plug it in the other way as well. G of f of x. This time we're taking this and plugging it into g, because we start in the middle, plug it in there. So 1/3 of our whole function f. Distribute and simplify. 1/3 times 3 is 1x. 1/3 times 9 is 3. And positive 3 and negative 3 are going to cancel each other out, just leaving us with x. Because we just get x, we know they're inverses. In your assignment, you'll have to show all this work, just so you know. Let's try this one more time. I've got two more different functions. F of x equals 4x squared, and g of x equals 2 times square root of x. And let's verify that they're inverses. Remember, we do f of g of x, and then we also have to do g of f of x, just to make sure that they work. F of g of x, we start in the middle. We take g of x, and we plug it in over there. 4 times 2 times the square root of x all squared. We distribute that. We get 4 times 2 squared is 4. Square root of x squared is x. And 4 times 4x gives us 16x, which is not just plain x. Which tells me already that these are not inverses. However, I don't like to leave a problem unfinished, so I'm just going to check it over here. F of x, plug it into g of x, so I get 2 times the square root of 4x squared. Square root of 4 is 2, square root of x squared is x, times 2 gives me 4x. Wait a minute, I know that if they're inverses, I'll end up with only an x. This is 4x, so again, not inverses. If you do one side and figure out that it's not equal to x, you do not have to do the second side. Like I said, I just like to do both sides to show you another example. But you can stop as soon as you get not an x. On this slide, both of them got an x, so yes, they were inverses. On this slide, you did not get a single x at the end, so they are not inverses. That's all for lesson 2. Here's your assignment. If you didn't realize, the pictures were all symbols from Monopoly.